Hello everyone, I'm Pouria. I'm a researcher in AI here at Onfido. I lead part of the research team at Onfido. We do certain things related to AI. We do things like biometric recognition, identifying documents, pictures of IDs, identifying fraud, and all those fall within the things that my group does. I'm going to tell you about a little bit about AI today, what it is, what it means, and at a high level, how it works. So the question is, what is AI? Can anyone tell me what it stands for? Just shout.
Artificial intelligence.
Great, yeah, sure. So artificial intelligence, right? So the clue might be in the words. Let's look at each word individually and see what they mean. What does artificial mean? Anyone?
Fabricated, like
Yep.
made.
Made up?
Yeah.
Yeah. Anything else?
Man-made.
Man-made? Yeah. In fact, Oxford Dictionary defines it as pretty much exactly that. Made or produced by humans rather than occurring naturally, especially as a copy of something natural. Intelligence. Oops, I wasn't supposed to do that. What does intelligence mean?
I guess the ability to learn, so to speak, like to project or like classify things without necessarily having seen them first, maybe?
That's a pretty good definition. Yeah.
To take information and then be able to process it and like
Process information, yes. Yeah.
Is it the ability to adapt to change?
Adapt and change, yeah. Yeah, those are amazingly good answers. So, it's all those things, but captured in a short sentence. Oxford says the ability to acquire and apply knowledge and skills. Now, so an artificial intelligent machine means putting those two together, something made by a human that has the ability to acquire and apply knowledge. Now, I don't feel like that got us very far, did it? Not a very good definition, or doesn't tell us much about what AI is. So I sometimes find that it's easier to understand concepts by thinking of what they are not, right? So let's think of what is not AI. Is a piece of rock AI? No. It's not artificial, and it's not intelligent. Is your math teacher AI? Or she might be a robot. No. Well, she is intelligent, but not artificial, right? Is a vending machine AI?
No.
it depends on the vending machine.
Depends on what? Can you elaborate?
What's in the vending machine, how it works. what
Normal vending machine, you put in some money, press a couple of buttons and get a cold drink. Probably not, right? Whoops, I don't know what I did there. It is on. Alright, is Alexa AI? Yeah? Anyone? Shout. There's a little bit of confusion, but I'm hearing more yeses than nos. I'm going to say yes, because it does something that the other ones, well, the teacher obviously does, but the vending machine doesn't. What does it do that makes it feel like a little bit more intelligent than a normal machine?
It collects data.
Collects data, yeah.
Like voice recognition, which doesn't necessarily have a simple rule.
Yeah. Same thing, sorry. You?
It kind of like gives it takes an input and then creates an output based off the input.
Processes information, and yeah, and last one.
it learns over time.
It learns over time. It does, but I'm not sure if it does that automatically. But yes, that is an ability associated with AI. But the one I was actually hoping you would say was just that to communicate in natural language, which you got, but you got a lot more than that. So amazing. You already mentioned some other things that are associated with human intelligence, things like processing information. I'm going to give some more examples here. Perception, perceiving what's around you in the environment. Planning, reasoning and making judgments based on your reason, representing your knowledge, so then you can plan based on that. Problem solving, creativity, these are all associated with human beings, with intelligence of human beings. And maybe above all, integrating all those skills towards common goals. So, if a machine has these properties, has these abilities, then you could safely say it's an AI, right? If a machine can do all of these, it's something amazing that we usually refer to as artificial general intelligence, which means an intelligence of a machine that is able to learn any intellectual task that a human being can learn and apply it to solving general problems. So not a specific problem, like Alexa can understand what you're saying, but she can't necessarily see around her, she can't identify objects. But if a machine can do everything generally, then that's artificial general intelligence. Does anyone have an example of an artificial general intelligence? It's also called strong AI, true AI, general AI. Anyone? Good, because they don't exist. We're not there yet. Artificial general intelligence is not solved yet. And most experts believe that we're at least a couple of decades away, if we ever get there. Some people believe that some problems associated with AGI will never be solved, like creativity. Some people think that machines will never be able to produce things that didn't exist before. Well, that's a debate still going on, but just to give you a glimpse into what they mean by that. So what do people talk about when they say AI? Is that all a lie? Does it not exist? Well, no, that's not true. What we hear today and see today as AI is as a more restricted definition, generally called narrow AI. Well, when they say AI, 99% of the time they mean narrow AI, also known as applied AI, which is the intelligence of a machine focused on solving a specific task. Not general problem solving, but a specific task. So that makes it a little bit more achievable, right? So Alexa has a series of narrow AI systems. She understands voice and converts it to text. She then does a search based on that text, and then she plays that result back to you. Each of those systems is a narrow AI. And the closest we've really got to that in the real world is, again, a subset of narrow AI called machine learning, which is a set of algorithms that consume a lot of data and extract knowledge from that data. Remember, we define intelligence as the ability to acquire knowledge. Machine learning is a set of algorithms that can acquire knowledge using examples of data of the real world. And I'll get an example of that. Machine learning has really enjoyed a lot of success recent years. In less than a decade, it has defeated the world champion in one of the most difficult games called Go. It has learned to translate between different languages, given us autonomous driving cars. A lot more examples as well. Most of that is down to progress in one particular field called deep learning, which is again a subset of machine learning. And in this field, people work with certain mathematical models called artificial neural networks. These are mathematical models inspired by the human brain that learn to represent knowledge using some complex mathematics, which are very complex in the back, but very accessible today as well. So that's where most of what you hear about AI these days lies. Remember, sometimes people talk about general AI when they're talking about something, they really mean general AI when they say things like, will it ever know if God exists? I mean, that is incredible. That's actually probably the most bizarre question I've ever heard this morning about the AI, and that's really interesting. But what they have in their mind is general AI. What we really have in the real world is machine learning and deep learning mostly. Now, I like to think of a machine learning model, an artificial neural network, as a big tunable machine with lots of different knobs to set. And you have to get all of them to the exact right value to get this machine to do what you want it to do, right? But there's millions of these knobs and parameters, so it's impossible for any human being to sit down and tune each of these parameters exactly to the right amount. Luckily, there is mathematical algorithms that do this for us. They take lots of data, put it through that algorithm, and the algorithm works out what the parameters of the machine can be. So here, the example is, I want to train a machine to identify cats. I throw in lots of different pictures of cats. The algorithm works out what the parameters of the machine should be so that it can detect a cat. So then, if a new cat is shown to the machine, it's able to identify it as a cat. How am I doing for time? Well, almost done anyway. So, that's a brief intro, but cat identification is not really the coolest example of AI, is it? What else can it do? Give me a couple of examples. What are some of the most interesting examples of AI you've heard?
This is just because I was working on this, but like handwriting recognition.
Handwriting recognition, yeah.
The ability to detect like financial fraud.
Detecting fraud, financial fraud, yeah, yeah. Good example. Anyone? Anyone? Yeah.
Facial recognition.
Facial recognition is certainly an application of AI, and it's very close to my heart because my team does exactly that. Anyone else? Yeah.
Analyzing patient data.
Analyzing patient data, yes, that's also a very interesting example. It also raises some questions about the ethics of that, right? If you leave what a doctor does to a machine, what sort of questions does it raise? We'll talk about some of those later on in the day. Some other examples are automatic driving cars, cars that can just drive themselves without a driver. These are now a reality. Google's AlphaGo that won a game against the world human champion in the game Go. Drug discovery is one of the very good applications of AI. It's applied to discovering drugs for diseases that are very hard to find manually. It can play games. Recently, some AIs have actually defeated humans at some video games. And so on. You can come up with 1,000 more examples as well. But this is an interesting one. I wish we had the... What do you think? So I'm going to stand over here. No. So this is a piece of music composed by AI. Played by... I actually don't remember which symphony, which orchestra is this. But anyway, the piece is composed by a machine. I'll just leave this playing while we give time for questions. Happy to take questions.
Which one?
Go.
Oh, okay. The type of like code I hear most often with AI is about like artificial neural networks, but like, are there other types of AI, and like, what are they?
Yes, there are. Let me just mute this. Okay, so there's. So if I go back to this slide on machine learning, there is. So over here is pretty much unexplored, but there's a lot of things going on in AI and in machine learning that are not in neural networks area. There's other algorithms in machine learning, mathematical algorithms that do similar things. The reason you don't hear much about them is, well, they're not as new, and most of the time they're not as powerful as neural networks are these days. Neural networks were very much in fashion in the 80s. Then they went out of fashion for a very long time, and they recently made a huge comeback in the 2010s, really, because of some advances in technology. Like, we have much more powerful processors now. We have a lot more data available, and some mathematical breakthroughs that were made. And these were put together. These made artificial neural networks very, very powerful, and made a lot of things possible that were not possible a decade ago. So that's why you hear most about them, but that doesn't mean there isn't any other.
What do you think is coming in the future of AI?
So future of AI, it's very hard to predict, especially the future.
Yeah. Might be easier with the microphone.
Do you want to repeat the question for the room?
What do you think the future of AI is?
Yeah, the future of AI is, well, it looks really exciting, whatever it is, because it has started very exciting. There's going to be a lot of things that machines will do that we don't even think about it today. There's going to be autonomous driving cars and stuff that you see here, that you hear about today, that those are really certainly coming and they will happen. But there's going to be a lot of things that we currently associate only with humans, like understanding, like interacting with people. It's going to affect how we interact with machines a lot, where I don't think in 10 years keyboards and mouse devices are going to be so common. We're going to use a lot more of our natural language to communicate with machines. They're going to be able to understand emotions. They're going to be able to really identify you truly, because what they do today is very close, but it has certain limitations. So as the field progresses, there's going to be less and less of those limitations. I don't know if it's ever going to take over the world. I don't think we're going to see that anytime soon. I mean, who's to say it's impossible, but yeah, my personal opinion is that that's not going to happen in any of our lifetimes. But it is going to open a lot of new doors that are currently considered impossible.
Do you mind, what's included in your work, your facial recognition, and how do you see facial recognition changing in the future?
So, how do you answer that?
Okay. What does your work in facial recognition include, and how do you see it changing in the future?
So, facial recognition is probably one of the more advanced areas in AI. It's already very powerful. The way it works is that, just like the cat example, you take millions of pictures of people, you feed it into your algorithm, then you use all the tricks in the book to make it tune particularly well to identify faces, to identify whether these faces are similar. Do they belong to the same person? Is it a live face or is it a picture of a face? Because I can take a picture of your face and present it to the camera and make it think I was you, right? So it needs to also understand if this is a real person or is it a picture of a person. Those things are already pretty advanced. The areas that are currently a little bit shaky are things like identical twins. Can you tell between two identical twins? People are not very good at that, so machines are not very good at that either. But I think that's one area to, the areas that it will advance more is more in the edge cases that are currently understudied. And then there's also a lot about 3D face recognition, because currently most of the work is on photos, but 3D sensors are a lot more available these days. So doing that in 3D using the shape, structure of the face and things like that is also another area that will develop soon.
Oh, wait.
What do you think about when people say that AI could lead to a lot of economic problems, because a lot of jobs may wind up disappearing because they'll be replaced by AI, and a lot of the jobs that will come up because of AI involve great skill, things like software development, there's mathematical things, and a lot of people who may not have those skills may wind up, becoming redundant because they're not necessarily able to do that. So what do you think about that?
So there's a great debate going on around that. A lot of jobs will definitely be changed, if not replaced, by AI. So that's almost a fact. But what would that lead to? Is it going to lead to people losing their jobs and not having any job, or is it going to change the nature of their job? That's a huge debate. Is it going to create new job opportunities? Is it going to create new things that don't exist today? Very likely. The Industrial Revolution changed a lot of jobs. A lot of jobs that existed before don't exist today. Riding horses is not a job anymore. Everyone drives a car. But there's more cars today than there were horses before. So there's a good chance that it will lead to new areas that people have not thought about today, that it would lead to jobs that don't exist today. Even today, it's not true that you only need computer skills to get a new job because of AI. There is other types of jobs that don't require any advanced skills, like, I talked about data. The data is useless if you don't tell the machine what it is. So you need a person to tell the machine what that data it's seeing is. So in the case of face recognition, for example, you need a person beforehand to say, these two are the same person. These two are not the same person. And that's a full-time job. We actually have hundreds of people doing that for us today. And they're not particularly skilled in computer skills. I mean, some of them might be, some of them might not be. You don't necessarily need those skills, that is what I'm trying to say. There are other opportunities even today. And as the field opens new doors, it will probably come up with a lot more opportunities.
Got a question?
Microphone. Okay.
How are we doing for time?
Another 5 minutes. And
This one will be quick, I promise. Isn't human intelligence also another narrow example of AI? If we think of it like an analogy of an ant swarm, you can think of a human being like an ant, and then from that there's a swarm intelligence emerging out of this. So we can think of civilization as a more general type of intelligence.
That is a good point. There is some debate around that, whether you can call a group of narrow AIs working together towards a common goal, whether you can call that general AI or not. Some people might agree that it is general AI, although even that is not really far beyond the intelligence of ants today. But some people say, no, that's still a group of narrow AI working towards one specific task, and you cannot throw any problem at it. A swarm of robots can not necessarily be creative in lots of different ways. Maybe it can be creative in the way it finds its path from this planet to another, but that's what it's trained to do. It can't be creative in composing music at the same time, right? So that's the idea around general AI. It's a general problem solver in the way that humans are.
How did you become interested in AI? Like, how did you start?
So I'm from Iran. I studied in Iran. I did my bachelor's degree in biomedical engineering. So I was looking at devices used in medicine and things used in hospitals, and that's where I started my career. There was a couple of particular courses that made me really interested. One was image processing, which was a course around how can a computer understand an image? How can you show a picture of an X-ray of someone's lungs who has lung cancer, and have a machine identify that? That was a very, that area was very intriguing and interesting to me. And then I came across this other module, which was an introduction to AI. And well, frankly, those two were pretty much the only modules I liked throughout my bachelor's. So after a while, I came to the UK, I started studying in the same field, and I ended up where I am today. No, nothing really, sorry if it's a disappointing story, I don't have a cool story to tell, but that's the reality, how it worked for me.
Okay, if no one has any more questions, you have one more question, go on.
Let's do the last one.
You were in your teens, right, and you heard your presentation and you wanted to get involved in AI. What other resources and what do you suggest we can use and they can use as the next step is to get more informed and to start getting involved into AI?
So there's lots of interesting courses online. I would suggest to start there if that's what I mean, to learn more about AI. There's a lot of material online, but I'm sure I don't need to tell you guys about the online world. That's probably the best way to go, because you need a structured way of understanding it and approaching it, at least at the very basic level. Otherwise, there's so much mythology around AI that you could easily get lost. You could get stuck in here and think about general AI for decades and it will still not be solved. But if you want to do something practical, you need to learn it systematically.
All right, thank you so much, Pouria. Thank you so much for your talk. Can we give her a round of applause?